Thank you very much, Dr. Seo. Please, can you confirm if you can hear me?
Yeah, I can hear you clearly.
Great. And good morning to everyone, to those in Korea and Hong Kong and those in other parts of the world. Good evening in the US and good afternoon. I don't know whether there are other people in the afternoon at the moment. And it's very nice to meet all of you from different parts of the world. And Dr. Seo has already given a very nice introduction about me. So thank him for that. And I'm not going to speak too much about myself. But before I start my presentation, I would like to make this very first part, a bit interactive. So I put a question that what do you think is the biggest problem in modular integrated construction projects? And you can feel free to type your views in the chat room, and later we will come back to this question again. So today we are at this seminar and I'll be presenting on the sustainable logistics planning in modular integrated construction projects. And what I'll be covering today, I'll first look at the 3 biggest challenges in MIC projects and how we can overcome those challenges. And we have done research to develop our own sustainable approach to overcoming these challenges. So the first solutions I'll be proposing is kind of general perspective or general views about how to solve these challenges. Then I'll present our own research outcome about how to overcome these challenges. So back to this question again, what do you think is the biggest problem in MIC projects? Feel free to type your answers in the chat room. I just want to hear what people think is the biggest challenge in MIC projects. This is my answer. Is it logistics? This is my own personal, bias about problems in MIC. Let me put it that way. And I think there's something in the chat room from Han. Thank you. Transportation due to the cost. Normally, our product is come from supplier with a delivery. Okay, that's good. Thank you for that. So someone thinks it's transportation. And I personally think it's logistics. But then I also look at the literature, and many people talk about the problems in MIC. And these are the 3 biggest problems I identify from the IQPC, and they put logistics first. So they tend to confirm my own personal feeling about MIC. And also they also mention about hookup, trying to hook everything up, bring everything together in MIC is really a challenge. And the next challenge is sequencing and also scheduling of the MIC project and processes. And the reason why I think logistics is the most difficult challenge, especially if you look at MIC from the perspective of Hong Kong, we are doing MIC in a very compact and very dense environment. Most of our sites are in very compact environments, and we have to transport the modules from outside Hong Kong, from mainland. And also, if you look at the situation in Singapore, it's almost the same as Hong Kong. They have to transport the modules from Malaysia, and also in a very dense, narrow roads and very compact environment. This is what makes MIC very challenging for those of us, especially in Hong Kong. I always believe our industry practitioners are very smart. They can solve the assembly challenges. It's not very difficult for them to assemble the products when they are on site. And so the logistics is the most difficult challenge. And in Dr. Wang's presentation, he also mentioned the transportation. We have to look at this issue very critically. And here is the case. We are actually implementing manufacturing philosophies and ideas in MIC. We are no more doing construction or traditional construction. If we really want to achieve success in MIC, then we have to look at it from the perspective of manufacturing philosophies and also supply chain philosophies. But these things are very new to us. How can we apply the best manufacturing strategies to achieve success in MIC. They are new to us construction practitioners. We are moving everything to manufacturing. So this is why the logistics is very, very difficult. And now researchers and practitioners from around the world are paying attention to this critical issue. So this is my personal view about the challenge. Let's look at what other researchers are saying. And I got this from Matthew. And I said that when the logistics planning is poorly done, that alone can kill the entire MIC project. And from their paper, they mentioned that the most glaring risk factor for MIC is the transportation of the models from the factory to the job site. This is a logistics issue. And they also think this process alone can prevent people from going modular. And when there is a mistake in the transportation process, that alone can cause a project that looks profitable to run into an absolute nightmare. And what constitutes this nightmare? It will lead to cost and other overruns in the MIC project. So this is why we have to look at MIC logistics very, very critically. And what are some of the overruns that can occur in the logistics in the MIC project due to logistics problems? So I try to look out for some MIC projects that encounter significant cost overruns. And then if you look at the report and the project documentation, what caused these problems, the logistics related challenges or delays contribute significantly to this kind of cost overruns. So a typical example is this project in Kazakhstan. It experienced a cost overrun of as much as 79 billion US dollars. And the delays in logistics was highlighted as one of the causes of these overruns. And another project in Australia that experienced cost overrun of 15 billion, and logistics delays again contributed to this kind of overruns. These are not the only failed MIC projects due to logistics problems. So my caution is we are promoting MIC because we think it has a lot of benefits. It can improve productivity, sustainability, and many other indicators in the construction process. But then we don't have to forget that MIC project can also fail significantly. So we have to look at the problems and solve these logistics challenges. How can we solve these challenges? So I looked at this reference manual from the CIC in Hong Kong, and I think this reference manual is very good, and they provided some good suggestions about how to solve the problems relating to transportation and logistics of the models in MIC. So first thing first, we have to think about the size of MIC models that can be manufactured, transported, and shipped to the construction site, especially from the Hong Kong perspective. If we have models that are above or have a width of more than 2.5 meters, then there might be some challenges with having to have police escort and having to transport sometimes in the midnight instead of during the day. So all this will increase the cost of an MIC project. And to solve this, we have to also look at the delivery route. How can the modules be delivered? What kind of route options do we have to deliver the models from the factory to the construction site? Normally, there might be a need for a traffic consultant to look at all these issues and help to establish the optimum routes for transporting the models from. So first, when we are trying to establish this, we have to think about the location of the factory and also the location of the project site. And then we know the best way to transport the models. And also we have two options here in Hong Kong to transport the models, whether by road or land or by sea, depending on one, the location of the factory, the location of the project site. And a question here we have to ask, is it possible to do just-in-time delivery at all? Most MIC projects will start with JIT in mind, thinking it could be done, but actually in practice, it's really, really difficult to do JIT for MIC project, especially in Hong Kong. In Singapore, I've visited a lot of Singapore projects, they call it PPVC, and they highlight, even though they aim to do JIT from the beginning, during the project implementation is really difficult. So we have to make arrangements for this if you really want to do this. So these are different scenarios that can be implemented to overcome the logistics challenges. But the question is, which one will be the best? What will be the impact of the different scenarios on the project performance indicators? This is what our research tries to do. So I'll present that later. And so in our research, we try to establish and try to understand from the practice point of view, the entire MIC supply chain, including the logistics. And we try to consider the fact that when we try to solve logistics problems, we shouldn't only focus on those problems. This is the problem in most previous research papers and modules developed to solve problems in MIC logistics, and also a problem in the industry. When we try to solve MIC logistics problems, we focus on only the logistics problems and try to solve them. But we want to challenge this thinking and say that, no, if you want to solve logistics problems, you have to also think about the problems in all the supply chain stages. Look at the problems in construction as well, look at the problems in the storage, and look at the problems in the cross-border checkpoint, especially if we are transporting across border. The reason why we want to promote this idea of looking at the linkages between all of them is that if you solve a problem in logistics, a decision made in construction can cause problems in logistics. So if you want to solve problems in one stage, look at the decisions made in the other stages as well. If you improve transportation and there is a delay in construction, it would definitely affect the delivery of the models. So what we want to argue here is that there is a great deal of interactions between the different stages. So if you solve problems with transportation, make sure you consider how those decisions made in transportation can impact the storage and how those storage decisions can impact transportation. So we try to look at all these different scenarios. You can see the flow of information from site to storage. We look at how the models flow from the different supply chain stages and try to simulate these kind of scenarios and try to find the best construction and logistics decisions to improve MIC KPIs. So what KPIs are we actually considering in our research? In construction, project duration cost is always important KPIs. But again, more recently, because of the need to address climate change, sustainability is even a much, much more important KPI. So we also look at the KPI from the sustainability point of view. And here we look at the CO2 emissions. And we also look at the utilization of the resources in MIC, such as the tower crane, the trucks, and look at the impact of different construction and logistics decisions on these KPIs and how they can be optimized in the MIC project. So how are we trying to do that? This is, we are doing mostly simulation. And here, this is an animation trying to understand the operations in the transportation or the logistics of the MIC. So you can see these trucks are moving from the factory storage and they are waiting here. This is the cross-border checkpoint. The reason why they waited there is because when the trucks get to the cross-border checkpoint, they have to wait for check-in. So this is a waiting time. So we try to simulate all the scenarios in reality. And then they move to the storage. So this is a situation or a scenario where there is a storage, temporary storage for the models. And then after they deliver to the storage, they will return back to the factory. And these trucks from Hong Kong, so we look at the Hong Kong situation where we have to transfer from mainland to Hong Kong. And then trucks from Hong Kong will move the models from the storage site to the construction site. And when they get here, they also wait for the trucks to be unloaded. So we look at all these reality scenarios and try to simulate them. And then we find the best decisions to improve the KPIs. And here, now we are at the stage where we are just doing this kind of simulation, and these positions of the factory and their locations are being assumed in our simulation. But we try to develop the simulation and connect it to the Google map in a way that we can actually get the actual positions of these different agents or stakeholders into the simulation model so that we'll be able to do something that is of reality. And so at the end, we try to develop a dynamic KPI dashboard for sustainable decision making. And this KPI has integrated different, this dashboard has integrated different scenarios in an MIC project. So decision makers can simply select a scenario. For instance, they want to use JIT, they want to use 10 number of trucks, or they want to use 5 cranes in the project. And with these scenarios, the dashboard will simulate and show you the impact on the different KPI. So it will show you the impact on time, the impact on costs, from transportation costs, storage costs, construction costs, the impact on CO2 emissions, and the impact on different other KPIs. So this is a system we've developed, and I have to mention that this is currently under review with Journal of Construction Engineering and Management. So that is why I'm not able to present all the methodology and everything we did, but this is the final outcome. And if you really want to know more about the methodology, we can always speak about that later on. And so this is just to show an animation. So for instance, if some scenarios are chosen in the dashboard, it will run this kind of simulation and try to find the best decisions. And it will show you the impact of each decision on these KPIs in an MIC project. So this really will help the practitioners and the stakeholders to make smart and sustainable decisions for the MIC project. And so the most important thing is that this system will help you to identify the significant decisions and how they interact with each other. So for example, here we are talking about the number of tower cranes. So for instance, if the project chooses to use only 1 tower crane, and with 12 here on the horizontal axis represent the number of trucks, and with 12 number of trucks, we are saying that these 2 decisions interact. So to make such decision, there is a need for collaboration between the construction site and other stakeholders involved in determining the number of trucks and the number of cranes, because these decisions will have an impact on the construction, the logistics costs. And it's the same thing here. If we choose to use JIT, we can ask the stakeholders, is the project duration more important? If you want to deliver the project very fast, the cost will increase. So this kind of decisions can be made using the system we have developed. So key findings we identify from this research is that when we apply JIT with more tracks, then it will lead to the least project duration. And also, if we are applying JIT, we have to use crane-mounted tracks. And when this is done, it will reduce the logistic cost because tracks in MIC can be flat-bedded tracks or crane-mounted. And also, when we want to use a storage area, we have to make sure we have more number of tracks. And this will help to reduce the logistics emissions. One might not understand the reason why if we have more trucks, the logistics emission will reduce. The reason is that with more trucks, the MIC models can be delivered in less number of trips or batches. And they can also be delivered in a time that will skip the rush hours. But then if the trucks are few, they have to go for more number of trips, and they can go in the morning and return to the storage or the factory to return more. And it's likely they will meet the rush hours and be in waiting time for long hours, and they will keep emitting more emissions. And also determining the number of cranes, the number of working hours, and the on-site storage capacity have significant impact on the construction costs. And so we try to identify some interactions between logistics and construction decisions and their impact on MIC KPIs. To conclude, we have proposed an approach that identifies the impact of significant logistics and construction decisions on different KPIs. This will help to monitor and manage the performance of MIC projects in real time. And we also test the impact of the different decisions on a virtual or in a virtual environment before we apply them in reality. And this helps to find the optimum logistics and construction decisions that can achieve mutual benefit for all stakeholders in MIC projects. Thank you very much. And if you'd like to speak more or know more about our research, please feel free to contact me on this email. Thank you.